December 17, 1903, Orville Wright, a young businessman who, together with his brother Wilmore, had founded a bicycle company, tried once again to fly. That Thursday of more than a century ago, if a person from 2021, for example you, had been there in Kitty Hawk, North Carolina, would probably have been disappointed since the Flyer 1 made a trip of only 120 feet of distance and 12 seconds in the air. However, those two intrepids that morning changed the world as we know it because they took the first step so that the small rock in which we live in a solar system on the outskirts of one of the 100,000 million galaxies became a world more united. 117 years later, on November 8, 2020, this happened. Josh Giegel, the co-founder and CEO of Virgin Hyperloop, and Sara, the director of passenger experience, were the first passengers in a new mode of transportation. Probably if that day of last year you had also been inside the capsule in Las Vegas, Nevada, you would have not been much impressed either, since the speed reached at 107 miles per hour is lower than that of high-speed trains, and its 15 seconds inside of Virgin Deathloop of only 500 meters would have seemed too little. But that day, one huge step was taken to achieve what will become the fifth means of transport. In this video, we're going to see in detail the Hyperloop, the means of transport that will change the world. Hi, this is Alejandro and welcome to the best moment in history. And right now you could help me make this video go faster than the Hyperloop if you liked it, right? No. Many thanks. You rock. Many times we think that innovation is driven by dreams, by wanting to achieve impossible goals, but this is not always the case. When Steve Jobs went to a party and a Microsoft employee told him how the new tablet from Bill Gates' company was going to do away with laptops and Apple should license Microsoft software, the CEO of Apple got a little bit angry. But as dinner dragged on, something happened that would change the course of history of tablets. In this dinner was like the 10th time he told me about it, and I was so fed up that when I got home I said, "Fuck it, we'll show him what a tablet can really be." Well, a similar anger, just a few years later, was the one that Elon Musk felt when he found out about this.
California train thing, like we know we've got like a bullet train that's like this, it has the dubious distinction of being the slowest bullet train and the most expensive per mile.
Go California!
We got some superlatives there. So we're setting records at both ends of the wrong ends of the spectrum, and so I think we can do something that's probably 10% of the cost, and I try to think of what are the attributes that you'd want in a new mode of transport. In fact, what is the theoretically fastest way that you could get from LA to San Francisco? Mm-hmm. And so the system I have in mind, which is you're guessing in the right direction. Sort of how would you like something that can never crash? Mm-hmm. It is immune to weather. It goes 3 or 4 times faster than the sort of bullet train that's being built.
Your supersonic jet.
Well, it goes about, let's say, an average speed of twice what an aircraft would do. So you go from downtown LA to downtown San Francisco in under 30 minutes. Mm-hmm. And it would cost you much less than an air ticket or cart, much less than any other mode of transport, because the fundamental energy cost is so much lower. And I think we could actually make it self-powering if you put solar panels on it. And I have a name for it, which is called the Hyperloop.
This exact moment was the first time Elon Musk named the Hyperloop. But after this interview, he continued to ponder the idea of a new means of transport, one that could do all the wonderful things that ran through his head, and this concern led to the fact that on August 12, 2013, he published the Hyperloop Alpha, a document in which he explained how this transport would be for the 21st century. However, he made a very unusual move, and it was that this document was not intellectually protected but the exact opposite. He open sourced it so that engineers from all around the world could work on it. In fact, he liked so much the fact of opening the knowledge that 1 year later, on June 12, 2014, Tesla opened all his patents. Because it's clear that when you want to change and improve the world, intellectual protection does not have sense. But the Hyperloop didn't end in this open document. In 2016, SpaceX held a competition between universities from all over the world to promote the construction of this train. Because really, when you see the Hyperloop, it doesn't look like more than a futuristic high-speed train. What is its difference with a train? To clarify this question, who better than him?
Our next award is the Propulsion Compression Subsystem Technical Excellence Award. And it goes to Maker's UPV team, University Polytechnic de Valencia.
Juan Vicén Balaguer, when he was 23, not only participated with several engineer friends at the SpaceX competition, but also won 2 awards. And driven by these triumphs, founded together with Daniel Orion and David Pistoni, Zeleros. 8 years after that event, in which they competed with 115 of the best universities in the world, such as Stanford, MIT or the UT of Munich, his Zeleros project is one of the 6 most important Hyperloop projects in the world. So Juan Vicén, what is this new system better to get around than a regular high-speed train?
El problema, ¿cuál es con los métodos de transporte convencionales? Pues,
so what is the problem with conventional transportation methods? Well, on the one hand, they face friction with the air. That is, if you take your hand out of the car window, there is a force that is the air that slows you down, right? And on the other hand, friction with the rail, which is that in the end all transport methods that touch the ground, so to speak, can face friction. So how can you reduce these 2 forces? So the aerodynamics, the one of the air, is achieved in the case of airplanes going very, very high. That is, the higher you go, the less air there is until you reach a space and we are in a vacuum, so to speak. And on the other hand, in Hyperloop, what is done, instead of having to go so high, you take a tube and inside that tube the air is extracted. The level of air at which is extracted varies between companies, but that is an option, right? It's very clear. This new means of transport uses a partial air vacuum in its tube to avoid the friction that Juan Vicén comments, and reducing it is crucial as aerodynamic drag increases with the square of the speed, and therefore the power requirement increases with the cube of the speed. Therefore, Hyperloop uses air extraction pumps in the tube that drastically reduce this resistance and the energy required to propel it. But this propulsion is not new. Since the concept of the engineer Robert Goddard in 1904 to those more recent proposals of the RAND and ET3, they already proposed vacuum transports. However, the latter was with a total vacuum, and the Hyperloop makes a partial vacuum since the total is very complicated and expensive for trips of hundreds of kilometers. In fact, Elon Musk's 2013 proposal of the Hyperloop Alpha coincides on this point with the current developments. And for the levitation, what does the Hyperloop do? Elon Musk proposed air bearing. That is, the air that enters through the giant front fan was compressed and later pushed between the walls of the tube and the cabin. Or, what is the same? This. But unlike air hockey tables, the air comes from inside the vehicle and not from the surface on which it glides. And in this point, how do the current Hyperloop projects are doing? There is none right now. No private company is proposing air bearings. They all use different levitation technologies and different magnetic propulsion technologies. Does this mean then that Elon Musk was wrong? To understanding what better thing we can do than see another challenge that Elon Musk had and everybody said it was impossible.
To make life multiplanetary is a fully and rapidly reusable orbit-class rocket. This is a very difficult thing to do because we live on a planet where that is just barely possible. If gravity were a little lower, it would be easy. If it was a little higher, it would be impossible. This has been attempted many times in the past, and generally what's happened is when people have concluded that success was not one of the possible outcomes, then the project's been abandoned. Now, we could fail. I'm not saying we're certain of success here, but we're going to try to do it.
And we all know what happened. SpaceX became the first and for the moment the only company in the world that manages to recover the first stage of its rockets. Levitation by air bearings being possible or not, the reality is that both Zeleros and the rest of Hyperloop projects have opted for MagLev technology, magnetic levitation in which a series of magnets make the Hyperloop hover and therefore there's no friction of any kind. But of course, for this to be possible, these magnets have to be very close to the metal of the walls of the Hyperloop. And as we have already said, the tube, although little, does have some air, and that is where the so-called Anthropic Limit occurs. Imagine for a moment that you want to empty the plunger of a syringe very quickly. It's very complicated. Well, in the same way, the Hyperloop at low speeds doesn't have any problems for the air to circulate through its walls. But when this limit is increased, it causes the air to accumulate in the front part and slow down the cabin. To solve this problem, the Hyperloop, through a compressor fan, manages to suck this air from the front and expel it from the back. In this way, not only is this obstacle avoided, but also serves as an aid to the propulsion. And for this propulsion, I want you now to think of an electric motor. For example, the one that you have in your magnificent Tesla. So right now you're imagining a rotor and stator. Well, what you have to do right now is to separate them and place the stator in the tube and the rotor in the cabin, and in this way, voila! Propulsion is achieved without the need for contact. In addition, this system, together with the low pressure due to the partial vacuum, makes it possible for the tube stator to be placed every certain space, since it manages to slide with these intermittent pulses as if you were on a skateboard. But which other benefits does it have? Well, it saves material and therefore cost, which was one of Elon Musk's objectives when he launched the idea, that the Hyperloop had to be an economical means of transport. For this saving objective, the Hyperloop also follows two other strategies, such as running on renewable energies that also benefit our planet, and another one that is less obvious. When making the construction of the tube on pylons, the land that is needed is minimal compared to a high-speed train track that needs about 30 meters in width. And, probably with the Hyperloop, the owners of the affected land will be proposed a system of renting their land as distribution companies already do with electrical towers. But this elevated system also manages not to fragment the land and avoid the catastrophes produced when trains run over people and animals. In addition, these tubes manage to avoid one of the most uncomfortable problems of transport, and that is the dependence on the weather. Snowfalls, torrential rains, hurricanes, and even sandstorms cause a multitude of flights and trains to be cancelled each year and roads cut. All this together with the fact that the tube avoids the possibility of derailment, prevents noise pollution, and that a system of dampers on the piles make it more resistant to earthquakes than the rest of land transports, made Hyperloop the transport of the future. But what if today we had the global Hyperloop network? Well, in that case, what before you needed hours, now you would need just minutes. So you could live in one city and work in another. You could be more productive since you would waste much less time traveling. This type of transport is ideal for distances between 250 and 1000 miles away. But why not more than 1000 miles? because above that distance, when electric planes will be a reality, they will be able to rise above the atmosphere and travel at supersonic speeds, and they will be able to make much shorter trips for flights of thousands of miles. But the advantages of the Hyperloop go far beyond comfort and speed. To understand what will happen in the future, what better way than to look backwards? If you were to review today the list of the richest people in history, 14 of those 75 billionaires were born in the same country and with only a difference of 9 years. Do you know when and where it was? In the US between 1831 and 1840. And what does it have to do with the Hyperloop? Well, between 1860 and 1880, when these lucky billionaires were in full maturity, the construction of the US rail system took place. Lady, gentlemen, young lady, young gentleman, the Hyperloop will be the most efficient, fastest transport for distances between 250 and 1000 miles with respect to the environment, and will also produce a wealth like we have never seen before. Hi, this is Alejandro, and welcome to the best moment in history. What do you think about the Hyperloop? Do you think that it will change our lives? You live in the best moment in history. Enjoy! If you have enjoyed this type of content, subscribe to this channel so you won't miss videos like this one. And I recommend you to watch this other video that I made just for you. Thank you very much from the heart.